Okay, so what we're working on right now is section 11.5, finding volume of prisms and cylinders. And so remember, volume is how much space you have inside of something. The formula for volume of prism is the area of the base, so it's a capital B times the height. The formula for a cylinder is the same thing because they have parallel congruent bases. It's the area of the base times the height. So these are both the same formulas. Now what's important is for each shape the base is different. For prisms, the base can be a rectangle, a square, a triangle, trapezoid, parallelogram. This kind of options are limitless. For a cylinder, though, the base is always a circle, and a circle's area is pi r squared. So sometimes people will write the formula as, oops, let's fix that, pi r squared times the height. But I would like you to focus on if they have congruent parallel bases, then it's the area of the base times the height, and then you just figure out what the base shape is. Okay, so here's an example. On the left, we have a volume of a prism. It doesn't matter for this one which is the base and which one's the faces, because in the end it ends up being the same because it's a rectangular one. But I'm going to highlight that this is the base. Okay? All right, and so now I always like to write my formula. The more you write it, you'll have it memorized. So that's helpful. So my base for this one is this rectangle. Now, I would like you to get in the habit of drawing the picture of the base. When we get to more complicated problems, it's going to make things easier. And so the area of this base is 12 times 5, which is 60. And then the height is this number here. So I'm going to times that by 4. So the volume of this shape is 240 units cubed. I didn't write whether it's inches or centimeters, so it's cubed. Okay? But that's it. You find the base. All right, this one over here, the cylinder, the base was already highlighted gray, but I'm still going to write my formula. Area of the base times the height. This is my base. Now, my base formula is, that's what I have. I got a diameter of 4, is pi r squared. So this is pi times my radius. And remember, radius is only half of it. So this is times 2 squared, which happens to be 4 pi. I mean, it just happens to be that. It won't always be the same as the diameter. Okay, so now my height is right here. So now I'm going to do 4 pi times 14. And you do not have to multiply by pi. If you actually leave pi in there, it's the most accurate answer. And so 4 times 14 is 56. So it's 56 pi units cubed. And that's the volume. So again, write the formula, draw the picture. That will help us when we get to harder problems. Okay, so here's the next one. So we know both of these is area of the base times the height. What I would like you to do for each one is I would like you to draw the shape of the base and find the area of the base for both of these. Once you think you have it, go ahead and press play. Okay, so you should have saw that the bases for this one happen to be those triangles. And so you should have drawn that front triangle. And this side over here doesn't really matter. The formula for a triangle is 1/2 base times height. And it gets confusing because it's another base. But lowercase b stands for the base of the triangle. So this is going to be 1/2 of 12 times 10, which happens to be 60. And now I'm going to times that by my height. Remember, the height is the distance between the two bases. So here's my yellow base up front. Here's my yellow base in the back. My distance between those two is 15. So I'm going to do 60 times 15. And so that's 900. And I have the measurement here. So it's 900 centimeters cubed. Okay. Over on the one on the right, you should recognize that it was a circle. And the radius this time, this radius right there is 2. So it's pi r squared. And so it's going to be pi times 2 squared, which is 4 pi. And so now we take that times the height. This is a slanted cylinder, but if you notice, height is always a right angle. It's perpendicular, and so that's my height right there. And so I'm going to times that by 3, and so I get 12 pi, and then inches cubed. And that's it. But again, I think the biggest thing is drawing this picture and finding the area. Some problems it will be a little easier, but when you get to the hard problems, this strategy is really going to help you. All right, so now we have this one. So this one, we're having to find the missing dimension. So for 3, we're having to find y. Okay, so my area is volume equals area of base times height. Well, I can't have a capital B here. I need to break this down. And this shape is a rectangle on the bottom. And so this is going to be length times width times height. And I'm going to plug in my numbers. My volume is 661.5. My length is 18. I don't know my width, so I'll say W. And my height is 3.5. Okay, so now I'm going to solve this problem. I'm going to combine those two by multiplying. So I do 18 times 3.5, and I get 63. So 661.5 is equal to 63y. And now you divide. I'm running out of space. I'll bring it up here. So 661.5 divided by 63 is 10.5. And so now I know that that missing measurement is 10.5. Okay, I'd like you to try number 3. At least see if you can set it up. We know that volume equals base times height. And now what's the formula for base, the area of the base? And then plug in the 75.63 and plug in the 6. And the P, because you don't know what P is. Okay, so you should have said that the area of the base is pi r squared times height. My volume is 75.36. I keep pi. You can actually, let's actually do this. Let's actually write 3.14. My radius, I don't know what that is. That's the P, so it's going to be P squared times height, which is 6. So I'm going to multiply those two things. So 3.14 times 6, that's 18.84. So 75.36 equals 18.84 P squared. Well, you divide. And so when I divide that, lots of decimals in this problem, huh? And I get 4, so P squared is 4. And then to get rid of a square, you take the square root. And so P is 2. So the radius of that problem was 2. Okay, so now what we're going to do is we're going to find the volume of this larger prism, given that these are similar. Okay, so remember when we did scale factor, it was just side over side. And area was side squared over side squared. But for volume, because it's in cubic, it's going to be side cubed over side cubed. And so let's do big over small. And the reason I'm doing big over small is because I'm missing this big volume. And so I'm going to put volume here. Okay, so I don't know what that is, so I'm going to call it X. And then this one's 360 because that's the volume of the small one. Now, the big shape, the only number I have is 24, but I have to cube that because it's volume. And it corresponds to this 12, so I cube that. And so now let's see, 24 cubed, that's a pretty big number. So I get X over 360 is the same as 13,824 over 12 to the third, which is 1728. And so now I'm going to divide those two, see if I get a whole number. And I do, so I get X over 360 is equal to 8. And then just to get rid of a 360, a divide by 360, you multiply by 360. And so my new volume is 2880. Oops, and then I need to write inches cubed. Okay, but the important thing is to remember that it's the sides cubed. Okay? Alright, so my hints again are drawing the picture on this volume. That's probably going to make the biggest difference when we get to harder problems.